Hi, my name is Gregory and I go to Hong Kong International School. For my project, I decided to make a frequency reader that could also tell what notes that frequency was. And I chose this project because it combined my two interests of music and computer science. And this is the first milestone in that project, which is just getting a basic frequency reader. Yeah, I'm going to give a demonstration of the frequency reader. Let me just make sure that, yes, everything is connected. So, uh, I'm gonna try and make this as big as possible. It might be a bit hard. Sorry, give me a moment, please. So, these values are the frequencies, and it picks up a lot of like frequencies from like outside, like me talking, for example. But I'm gonna be quiet and hold on. Sorry. And sorry, I'm going to play this B flat note, and it'll read the frequency. Hold on. Sorry, give me a moment. I have to. Okay, so I don't know if you saw it, but the frequency chart said 121, and the frequency of the B flat note that I played is usually about 120, but because of some because of a slight lack of tuning when I recorded that note, it came out as 120 to 121. And now I'm gonna explain all the technical components of my Arduino and the speaker and my project. So first of all, there's this, and I'm gonna take it off of the board. Actually, this is the sound sensor module that reads the sound input and can translate it. And the cool part about it is that it can translate it into either a digital input, which is, or an analog output, which is what I used. Uh, this is this is the Arduino Uno, and what this does is it can take the signals that the sound sensor gave, and it can uh, apply some code to them, which is the frequency reader. And this USB-B to C cable is what transports the code into the Uno and allows it to function and take the signals from the sound sensor. Some challenges I had with this project were, first of all, getting a high enough sample rate, because in order to measure frequency, you need to get a lot of samples. Most music studios use around 44 to 48, and 44 to 48 kilohertz worth of samples. And the Arduino and the analog read function on the Arduino, which is how I was initially grabbing samples, were too slow to meet that requirement. So I had to incorporate a new code that was able to get to a much higher sampling rate. The next challenge that I had was reading frequency, because the because it was and finding out how to conduct fast Fourier transforms, which are how frequencies are calculated from analog signals like the one that I had. Um, I overcame this with the help of the instructors, who gave me some helpful articles that I used to get a good frequency calculation uh, code. Next, in my project, like for the next milestone, I'm going to try and make it so that it can take a frequency within a certain range and associate that frequency with a music note. Like the note that I just played was a B flat, so I'd make it so that the serial monitor could print out a B flat.